79er, and EMS was plus 3.3, over.
Roger, plus 3.3 on the EMS.
Because the stage was a part of the vehicle for an extended period, it contained an auxiliary propulsion module for attitude control. Two APS modules were mounted 180 degrees apart on the aft skirt assembly. Each module contained three 150-pound thrust engines and one 70-pound thrust ullage motor. The Apollo 11 third stage, with its aft interstage, was placed above Stage 2 on March 5, 1969. The first stage of the Apollo 11 Saturn V, designated S1C6 for the sixth flight stage, arrived at the Kennedy Space Center on February 20, 1969. Because of their large size, Saturn V stages were shipped to the Kennedy Space Center by ocean-going vessels and specially designed aircraft. The Saturn V was the first large vehicle in the U.S. space program to be conceived and designed for a specific purpose, that of landing a man on the moon and returning him safely to Earth. The birth of the Saturn V can be dated to January 10, 1962, when NASA formally announced development of the Big Booster. The 300,000-pound first stage is 33 feet in diameter and 138 feet long. At liftoff, it held nearly 4.5 million pounds of propellant, consisting of RP-1, a form of kerosene for fuel, and liquid oxygen as oxidizer. The first stage generated a total thrust of around 7.5 million pounds, operating for just 2.5 minutes to lift the vehicle to an altitude of about 38 miles at burnout. The awesome power of the Saturn V first stage was generated by 5 F1 engines. Each F1 engine was a single start, 1.5 million pound fixed thrust engine. All of the engines were identical with one exception. The outer four swiveled or gimbaled for steering control. The center engine was fixed. The expense of the Saturn V makes it imperative that no effort be spared to assure that it will perform as expected in flight. The magnitude of the Saturn V ground test program was unprecedented. To qualify for flight, all components and systems had to meet standards deliberately set much higher than actually required. The inspection to which flight hardware was subjected was thorough. X-rays were used to inspect fusion welds, 100 castings and 5,000 transistors and diodes. A quarter mile of welding and 5 miles of tubing were inspected with the use of ultrasonics. The same type of inspection was given to adhesive bonds, which are equivalent in area to an acre. An electrical current inspection method was used on 6 miles of tubing, and dye-penetrant tests were run on 2.5 miles of welding. Each contractor had its own test program that was patterned to a basic conservative approach. Qualification testing of parts, subassemblies, and assemblies was performed to assure that they are capable of meeting flight requirements. Reliability analysis was conducted to determine the range of failures or margins of error in each component. A battleship test stage constructed more solidly than a flight stage was used to prove major design parameters. The stage verified propellant loading, tank and feed operation, and engine firing techniques. Battleship testing was followed by all systems testing. Finished work undergoes functional checkout to ensure it meets requirements. Fluid-carrying components are subjected to pressures beyond normal operating requirements. Rocket engines were static fired before delivery to the stage contractor, and each stage underwent testing leading to a full-power captive acceptance firing. After refurbishment and a post-firing checkout, it was shipped to Kennedy Space Center. Upon arriving and being offloaded at the dock, the stage would enter a low bay of the VAB, or Vehicle Assembly Building. The VAB consists of a high bay area 525 feet tall, a low bay area 210 feet tall, and a 4-story launch control center connected to the high bay by an enclosed bridge. There are 4 assembly and checkout bays in the high bay area. The low bay contained 8-stage preparation and checkout cells equipped with systems that simulated stage interfaces. Saturn V stages went into the VAB low bay area where preparation and checkout began. After being towed into the high bay area and positioned under the 250-ton overhead crane, slings were attached to the first stage and attached to the crane. The stage is lifted to a vertical orientation and then positioned over the mobile launcher. At this stage in the process, the first stage is still missing the engine nozzle extensions and fairings and fins. These will be added later. The VAB had 141 different lifting devices at the time of the Saturn V, ranging from 1-ton mechanical hoists to 2 250-ton high bay bridge cranes. Each pair of high bays shares a bridge crane. The cranes have a lifting range of 456 feet and a travel distance of 431 feet. When the stage is positioned over the mobile launcher, it is lowered into place. Then it is secured to 4 hold-down and support arms. These support the entire space vehicle during launch preparation and provide hold-down during thrust buildup prior to launch. The second stage for the Apollo 11 Saturn V S-26 arrived at Kennedy Space Center on February 9, 1969. On the Saturn V, the second stage employed cryogenic propellants of liquid hydrogen and liquid oxygen. For the lunar mission, the second stage takes over from the first stage at an altitude of about 38 miles and boosts its payload of the Saturn V third stage and the Apollo spacecraft to approximately 114 miles. When its 5 J2 engines ignite, the stage is pushing more than 1 million pounds. Speed of the stage ranges from 6,000 miles per hour to 15,300 miles per hour. The beginning of the second stage boost is a 2-step process. When all the F1 engines of the first stage have cut off, the first stage separates. Ullage rocket motors around the base of the second stage then fire for approximately 4 seconds to give positive acceleration to the stage prior to engine ignition. About 30 seconds after the first stage separation, the part of the second stage structure on which the Ullage rockets are located, the aft interstage, is separated by firing explosive charges. This second separation is a precise maneuver. The 18-foot high interstage must slip past the engines without touching them. With the stages traveling at great speed, the interstage must clear the engines by only a little more than 3 feet. The second stage burns for about 6 minutes, pushing its payload into space. The 81-foot second stage is basically a container for its 942,000 pounds of propellant, with engines attached at the bottom. Propellants represent more than 90% of the stage's flight weight. The stage is constructed mostly of lightweight aluminum alloys ribbed in such a fashion that it is rigid enough to endure the pressures to which it is subjected. Special lightweight insulation had to be developed to keep its cryogenic propellants from warming. The second stage developed its power through 5 Rocketdyne J2 engines, a high-performance upper stage propulsion system. Each engine developed a maximum vacuum thrust of 225,000 pounds. All J2 engines were identical when delivered. They all were designed to be restarted in flight. The restart capability is only used in the third stage. As in the first stage, the outer four engines in the second stage gimbal, while the center engine is fixed. The second stage of the Apollo 11 Saturn V was erected at the top of the first stage on March 4, 1969. Using the 250-ton bridge crane, the stage was lifted into position with the aft interstage attached. The Apollo 11 Saturn V's third stage was moved into the VAB for checkout on January 21, 1969. The Saturn V third stage was an oxygen-hydrogen stage derived from the S4 stage originally created as part of the Saturn I program. The S4B stage was also used as the second stage for the Saturn 1B. The third stage had a maximum thrust on one J2 engine of 225,000 pounds. The stage was used for the final Earth orbital insertion and reignited to place the Apollo spacecraft on a translunar trajectory. The stage burned for about 2 3/4 minutes for orbital insertion and about 5.5 minutes for translunar injection.
Ignition.
We confirm ignition and the thrust is go.
Guidance looking good. Velocity 26,000 feet per second. Cut off. We're showing velocity 35,570 feet per second, altitude 177 nautical miles.
Apollo 11, this is Houston. We show cutoff and we copy the numbers in noun 62. Apollo 11, Houston, do you read? Apollo 11, this is Houston. Do you read, over?
Roger, Houston, Apollo 11. We're reading a VI of 35579er, and the EMS was plus 3.3, over.
Roger, plus 3.3 on the EMS.
Because the stage was a part of the vehicle for an extended period of time, it contained an auxiliary propulsion module for attitude control. 2 APS modules were mounted 180 degrees apart on the aft skirt assembly. Each module contained 3 150-pound thrust engines and 1 70-pound thrust ullage motor. The Apollo 11 third stage, with its aft interstage, was placed above Stage 2 on March 5, 1969. The instrument unit is the Saturn V's nerve center. It contains the electronic and electrical equipment needed for guidance, tracking, and communications of vehicle environmental and performance data. The IU also contains environmental control equipment for temperature control, batteries, and power supplies to furnish operating power for electronic equipment. The stage structure is 260 inches in diameter and 36 inches high and becomes a load-bearing part of the vehicle. It supports the components within the IU and the weight of the spacecraft. Several tracking systems are used to follow vehicle trajectory during ascent and orbit. Vehicle antennas and transponders, which increase ground-based tracking systems' range and accuracy, make up the IU's tracking equipment. The Saturn V is equipped with lots of equipment designed to detect malfunctions. Some of this equipment checks engine thrust and monitors guidance computer status, attitude rates, angle of attack, and abort request. This emergency detection information is flashed to the IU where it is routed to the emergency detection distributor in the electrical system. In the case of an emergency, the system will turn on a light in front of the astronauts. If the spacecraft abort selector switch is in the automatic abort position, the abort will take place without further crew participation. The action cannot be vetoed by the astronauts. However, if the selector switch is in the manual position, the crew makes the decision when to abort a mission. The Apollo 11 lunar module, LM-5, was designated as Eagle by the crew. The lunar module is a two-stage vehicle designed for space operations near and on the Moon. The LM is not capable of re-entering the atmosphere and was the first manned spacecraft designed solely for operation in space. The lunar module stands 22 feet 11 inches high and is 31 feet wide diagonally across the landing gear. Joined by 4 explosive bolts and umbilicals, the ascent and descent stages of the LEM operate as a unit until staging, when the ascent stage functions as a single spacecraft for rendezvous and docking with a CSM. 3 main sections make up the ascent stage: the crew compartment, midsection, and the aft equipment bay. Only the crew compartment and midsection are pressurized at 4.8 pounds per square inch. The cabin volume is 235 cubic feet. The descent stage consists of a cruciform load-carrying structure of 2 pairs of parallel beams, upper and lower decks, and enclosure bulkheads. The center compartment houses the descent engine, and descent propellant tanks are housed in the 4 square bays around the engine. The descent stage measures 10 feet 7 inches high by 14 feet 1 inch in diameter. In a retracted position until after the crew mans the LEM, the landing gear struts are explosively extended and provide lunar surface landing impact absorption. The main struts are filled with crushable aluminum honeycomb for absorbing compression loads. Foot pads 37 inches in diameter at the end of the landing gear provide support on the surface. Each pad except the forward pad is fitted with a lunar surface sensing probe which signals the crew to shut down the descent engine upon contact with the lunar surface. Eagle had a launch weight of 33,205 pounds. CSM-107, Apollo 11's Command and Service Module spacecraft, was designated as Columbia by the crew. It consisted of a service module 12 feet 10 inches in diameter and 24 feet 7 inches high. For the Apollo 11 mission, it weighed 51,243 pounds at launch. Aluminum honeycomb panels 1 inch thick form the outer skin, and milled aluminum radial beams separate the interior into 6 sections around a central cylinder containing 2 helium spheres, 4 sections containing service propulsion system fuel and oxidizer tankage, another containing fuel cells, cryogenic oxygen and hydrogen, and 1 section essentially empty. The service propulsion system provided thrust for large spacecraft velocity changes through a gimbal-mounted 20,500-pound thrust hypergolic engine using a nitrogen tetroxide oxidizer and a 50-50 mixture of unsymmetrical dimethylhydrazine and hydrazine fuel. The command module is a pressure vessel encased in heat shields, cone-shaped 11 feet 5 inches high with a base diameter of 12 feet 10 inches and a launch weight of 12,250 pounds. The command module consists of the forward compartment, which contains 2 reaction control engines and components of the Earth landing system, the crew compartment or inner pressure vessel containing crew accommodations, controls and displays, and many of the spacecraft systems, and the aft compartment housing 10 reaction control engines, propellant tankage, helium tanks, water tanks, and the CSM umbilical connection. The crew compartment contained 210 cubic feet of habitable volume. The command module Earth landing system includes the drogue and main parachute system, as well as post-landing recovery aids. In a normal entry descent, the command module forward heat shield is jettisoned at 24,000 feet, permitting mortar deployment of 2 reefed 16.5-foot diameter drogue parachutes for orienting and decelerating the spacecraft. After drogue release, 3 mortar-deployed pilot chutes pull out the 3 main 83-foot diameter parachutes with 2-stage reefing to provide gradual inflation in 3 steps. 2 main parachutes out of 3 can provide a safe landing.
Apollo 11, Houston, you're a go for TEI, over. Apollo 11, thanks.
This is Apollo Control at 134 hours, 48 minutes. It continues very quiet here in Mission Control. The flight controllers have been observing the crew inputs to their computer, monitoring as the crew prepares for the trans-Earth injection burn, scheduled to occur at about 35 minutes from now. This is Apollo Control. We're now less than 30 seconds from the time at which trans-Earth injection is scheduled, the burn to start Apollo 11 on its trajectory back to Earth. We're now 15 seconds from the scheduled ignition time. That burn will last about 2 minutes 28 seconds and consume 10,000 pounds of propellant. And the crew should be burning at this time. Of course, that maneuver is performed on the backside of the moon. We have no data from the spacecraft here in Mission Control at this time. We won't know how the burn went for about another 10 minutes, which is the time at which we're scheduled to reacquire Apollo 11.
AOS.
And there's the cue. We have acquisition of signal.
Hello, Apollo 11, Houston, how did it go, over? Help to open up the LRL doors, Charlie. Roger, we got you coming home. It's well stocked.
At launch, the lunar module is housed in the spacecraft lunar module adapter section. This is a truncated cone 28 feet long extending from the top of the instrument unit to the bottom of the service module. The entire assembly of CSM, LEM, and spacecraft lunar module adapter are assembled, moved to the VAB and erected atop the third stage of the launch vehicle.
There she goes. It was a good one.
Roger, Dodger. We got Eagle looking good. It's holding cabin pressure, and it picked up about 2 feet per second from that jettison.
I believe that. I can see some cracks in outer coating around the tunnel. In the thermal protective coverage. I don't think it has anything to do with structure.
Roger. Hello, Columbia, Houston. We'll have a attitude and a little blip burn for you at about 130.30 so we can separate from Eagle, over.
That's fine.
Columbia, Houston, would you start a maneuver to about pitch of 230 for this little tweak burn, over?
Roger, pitch 230.
Raj, Mike, can verify track mode in auto for the high gain.
The crewmen of Apollo 11 spent more than 5 hours of formal crew training for each hour of the mission's 8-day duration. This training included detailed briefings on spacecraft systems, operation and modifications, Saturn launch vehicle briefings on countdown, range safety, flight dynamics, failure modes, and abort conditions. Briefings were held and continuous training done on mission photographic objectives and use of camera equipment. Stowage reviews and practice in training sessions in the spacecraft mock-ups and command module simulators allowed the crewmen to evaluate spacecraft stowage of crew-associated equipment. More than 400 hours of training per man in command module and lunar module simulators were conducted, along with entry corridor deceleration profiles at lunar return conditions in the centrifuge. Lunar surface briefings and 1G walkthroughs of lunar surface EVA operations were conducted. In addition, the crew became familiar with the flight hardware through visits to the manufacturing facilities and through altitude chamber runs with both spacecraft. In these runs, the spacecraft were placed in a condition simulating flight pressure. The mobile launcher is a transportable launch base and umbilical tower for the space vehicle. 3 mobile launchers were used at Launch Complex 39. The launcher base is a 2-story steel structure, 25 feet high, 160 feet long, and 135 feet wide. It is positioned on 6 steel pedestals 22 feet high, both in the VAB and at the launch pad. At the launch pad, the launcher was also stiffened by 4 extendable columns designed to counter rebound loads if the Saturn engines cut off. The umbilical tower, extending 398 feet above the launch platform, is mounted on one end of the launcher base. A hammerhead crane at the top has a hook height of 376 feet above the deck. The 12 million pound mobile launcher stands 445 feet high when resting on its pedestals. The launch vehicle sits over a 45-foot square opening which allows an outlet for engine exhaust into the launch pad trench containing a flame deflector. This opening is lined with a replaceable steel blast shield, independent of the structure, and is cooled by a water curtain initiated 2 seconds after liftoff. There are 9 hydraulically operated service arms on the umbilical tower. These service arms support lines for the vehicle umbilical systems and provide access for personnel to the stages as well as the astronauts to the spacecraft. On Apollo 11, one of the service arms is retracted early in the count. The Apollo spacecraft access arm is partially retracted at T-minus 43 minutes. A third service arm is released at T-minus 30 seconds and a fourth at about T-minus 16 seconds. The remaining 5 arms are set to swing back at vehicle first motion. The Apollo Access Arm, Service Arm 9, located at the 320-foot level above the launcher base, provides access to the spacecraft cabin for the closeout team and astronaut crews. The flight crew boards the spacecraft starting at about T-minus 2 hours 40 minutes. The Apollo 11 vehicle is secured to the mobile launcher by 4 combination support and hold-down arms mounted on the launcher deck. The hold-down arms are cast in one piece, about 6 by 9 feet at the base and 10 feet tall, weighing more than 20 tons. Damper struts secure the vehicle near the top. After the engines ignite, the arms hold Apollo 11 for about 6 seconds until the engines build up to 95% thrust. The arms release on receipt of a launch commit signal at the 0 mark in the count. The vehicle is prevented from accelerating too rapidly by controlled release devices. The 6 million pound transporters move mobile launchers into the VAB and mobile launchers with assembled Apollo space vehicles to the launch pad. They are also used to transport the mobile service structure to and from the launch pad. 2 crawler transporters were constructed and are still used today to transport space shuttle vehicles. Maximum speed of the transporter is about 1 mile per hour loaded. The 3.5-mile trip to Pad A with Apollo 11 took about 6 hours. The transporter has a leveling system designed to keep the top of the space vehicle vertical within plus or minus 10 minutes of arc, about the dimensions of a basketball. The system also provides leveling operations required to negotiate the 5% ramp which leads to the launch pad and keeps the load level when it is raised and lowered on pedestals. The transporter moves on a roadway almost as broad as an 8-laned highway and is designed to accommodate a combined weight of about 18 million pounds. The roadway was built in 3 layers with an average depth of 7 feet. The base layer is 2.5 feet of hydraulic fill. The next layer consists of 3 feet of crushed rock. The top is covered with a cover of river rock, 8 inches deep.
This is Apollo Saturn Launch Control. We're at T-minus 2 hours, 55 seconds and counting. We're approaching the 2-hour mark in our countdown, and we appear to be proceeding satisfactorily at this time. The crew aboard the spacecraft at 320-foot level. The hatch is closed, and we're beginning to purge the cabin to bring it to the proper atmosphere full launch, which is a combination of oxygen and nitrogen, 60% oxygen and 40% nitrogen atmosphere. Of course, the astronauts themselves are breathing pure oxygen through their spacesuits. Coming up shortly will be another key test in which both the launch crew for the launch vehicle crew and the spacecraft team combine together with the commander, Neil Armstrong, to make a thorough check of the emergency detection system. This is the system that will signal the astronauts in the cabin if anything goes wrong below them. We use the ground-based computer to accomplish this test. It's rather lengthy as these tests go using a computer. It will take some 30 minutes. Neil Armstrong will be doing most of the work in the spacecraft, responding as different cue lights signifying different difficulties are presented to him. The abort panel, of course, is across from the commander on the left-hand side, the left front of the spacecraft. Our countdown continuing, T-minus 1 hour, 59 minutes, 34 seconds, and counting. This is Kennedy Launch Control. This is Apollo Saturn Launch Control, T-minus 1 hour, 50 minutes, 55 seconds, and counting. We're proceeding with the countdown for the Apollo 11 mission at this time, and it's going satisfactorily. At this point, the spacecraft commander, Neil Armstrong, in the process of working the emergency detection system test. This is a check of the emergency detection system, working with the launch crew here in the firing room, and also the spacecraft team in control rooms back at the Manned Spacecraft Operations building here at the Kennedy Space Center. All going well with these tests at the present time. We're flowing hydrogen back into the third stage of the Saturn V launch vehicle after having difficulty with that leaking valve. It appears that we are bypassing the use of the valve directly in loading the hydrogen aboard, but we are getting the hydrogen back in to replenish the supply. All appears to be going well at this time. Weather is go. We're coming up on 1 hour and 50 minutes. This is Kennedy Launch Control. This is Apollo Saturn Launch Control, T-minus 1 hour, 40 minutes, 55 seconds, and counting. The countdown is still proceeding very satisfactory at this time as we lead up toward our planned liftoff time of 9:32 a.m. Eastern Daylight. The spacecraft commander, Neil Armstrong, continuing this extensive series of checks of the emergency detection system, working with both the launch vehicle test crew and the spacecraft crew. This is a key test and a very thorough test to assure ourselves before we commit to liftoff that all the emergency detection techniques inside the launch vehicle are operating properly here on the ground, so if required in flight, the spacecraft commander and, of course, his two fellow astronauts could be signaled of a difficulty inside the rocket and could take proper abort action as required. Thus far, the three astronauts aboard the spacecraft have just been giving business-like responses back to the directions and checks, working with the spacecraft conductor, Skip Chauvin, as he runs down his procedures as the countdown continues. For T-minus 1 hour, 39 minutes, 46 seconds and counting. This is Launch Control.
Just like this.
This is Apollo Saturn Launch Control, T-minus 1 hour, 30 minutes, 55 seconds, and counting. All elements are go with the countdown at this time. The countdown aimed toward landing 2 astronauts on the moon. At this time, the spacecraft test conductor, Skip Chauvin, going through some checks with astronaut Mike Collins aboard the spacecraft. We're winding up this important emergency detection system test that Neil Armstrong has been participating in. Meanwhile, at the 320-foot level, the closeout crew now placing the boost protective cover over the hatch now that we have completed the cabin purge and have the proper environment inside the cabin. We have also performed leak checks to assure ourselves that the cabin atmosphere is valid. This boost protective cover is used during the early phases of the powered flight and is jettisoned with the escape tower shortly after second stage ignition. Here in the firing room, the launch vehicle test team still keeping a close eye on the status of the propellants aboard the Saturn V launch vehicle. We're back to 100% supply with the liquid hydrogen fuel in the third stage. This problem with the leaking valve is no problem at this time. We've actually bypassed the valve, but we are maintaining our hydrogen supply aboard the vehicle. All aspects go. The weather is very satisfactory for launch this morning. A thin cloud cover about 15,000 feet. Temperature at launch time expected to be about 85 degrees. T-minus 1 hour, 29 minutes, 30 seconds, and counting. This is Kennedy Launch Control. This is Apollo Saturn Launch Control. T-minus 1 hour, 20 minutes, 55 seconds, and counting. All still go with the countdown for Apollo 11 at this time. At this point in the countdown, spacecraft commander Neil Armstrong once again appears to be the busiest worker in the spacecraft as he's performing a series of alignment checks associated with the guidance system in the spacecraft. He's working these checks with the spacecraft test conductor as the spacecraft test conductor reads off the various procedures and Armstrong responds to them. The astronauts aboard the spacecraft also were informed by the spacecraft conductor a short while ago that the launch vehicle is go at this time. The hydrogen problem that we did encounter earlier has been solved. That's real good news, said Armstrong, and then he went back to work shortly thereafter. We're now coming up on the 1 hour, 20-minute mark in the countdown. This is Kennedy Launch Control. This is Apollo Saturn Launch Control. T-minus 1 hour, 11 minutes, 55 seconds, and counting. The countdown for Apollo 11 still going very satisfactorily at this time. In most cases, we're a matter of 5 or 10 minutes ahead of the countdown procedures. The crew in the White Room at the 320-foot level who have been aiding the astronauts up to this time are just in the process of finishing up their work. They've been advised by the spacecraft test conductor that they'll probably be able to move out in about 3 minutes or so. Once this is accomplished, once the closeout crew does depart, we'll be ready to move that swing arm back, swing arm 9. It will be moved 12 degrees away from the spacecraft hatch. This is about 5 feet away from the hatch. Once this is accomplished, we will arm the pyrotechnic systems in the spacecraft so in the event of a possible catastrophic condition below them with the launch vehicle, while still on the pad, the astronauts could fire that escape rocket and separate from the rocket in difficulty. The closeout crew about to depart at this time. That swing arm remains about 12 degrees away from the spacecraft hatch, as mentioned, 5 feet or so, until the 5-minute mark in the count when it's fully retracted to its fallback position. The obvious reason here is in the event we do have to get the astronauts out in a hurry, the swing arm is in a standby position and can be moved rapidly back to the hatch level so the astronauts could depart in the event of an emergency. We're coming up on T-minus 1 hour, 10 minutes, and 20 seconds. This is Kennedy Launch Control. This is Apollo Launch Control at 1 hour, 7 minutes, 25 seconds, and counting. Countdown still proceeding satisfactorily. For those people who would like to synchronize their watches in relation to the count, will synchronize on 26 minutes past the hour, which is now about 65 seconds away. We'll count down the last 5 seconds to 26 minutes past the hour. We're now 1 minute away from 26 minutes past the hour. In the meantime, we do have information from the civil defense agencies in the area. The estimate is more than 1 million persons are in the immediate area in Brevard County to watch the launch. Now 40 seconds away from 26 minutes past the hour. Civil Defense Agency reports further that there is extensive heavy traffic, a number of traffic jams, particularly in the area of Titusville, near US 1 and Route 50. Countdown still progressing satisfactorily, 15 seconds away from 26 minutes. Five, 4, 3, 2, 1, mark. 8:26 a.m. Eastern Daylight Time. We're now 1 hour, 5 minutes, 55 seconds and counting as it was announced at that point. This is Kennedy Launch Control.
That's right.
This is Apollo Saturn Launch Control, T-minus 61 minutes and counting. T-minus 61 minutes on the Apollo 11 countdown, and all elements are go at this time. Astronaut Neil Armstrong has just completed a series of checks on that big service propulsion system engine that sits below him in the stack. We want to assure ourselves before liftoff that that engine can respond to commands from inside the spacecraft. As Neil Armstrong moved his rotational hand controller, we assured ourselves that the engine did respond by swiveling or gimbaling. This, of course, is important for maneuvers in space. The countdown is still proceeding very satisfactorily, other than 2 minor problems. Since we picked up the count at 11 p.m. Eastern Daylight Time last night, all has gone well. As we approach the 1 hour mark now in the count, a series of radio frequency and telemetry checks will be in progress with the launch vehicle. We'll also check out the tracking beacons in the instrument unit that travels as a guidance system for the Saturn V during the powered phase of flight. Now 59 minutes, 48 seconds and counting. This is Kennedy Launch Control. For Saturn Launch Control, T-minus 2 hours, 40 minutes, 40 seconds and counting. At this time, the prime crew for Apollo 11 has boarded the high-speed elevator from inside the A level in the mobile launcher, which is the second level inside the launcher. This is a high-speed elevator, 600 feet per minute, which will carry them to the 320-foot level, the spacecraft level. Shortly, we'll expect astronauts Neil Armstrong and Michael Collins to come across swing arm 9, the Apollo access arm, and proceed to the White Room and stand by to board the spacecraft. The third member of the crew, astronaut Edwin Aldrin, who will be the last one to board the spacecraft, will stand by in the elevator, seated in a chair, while his 2 comrades first board the spacecraft. Once Armstrong, who sits in the left-hand seat, and Collins, who will sit in the right-hand seat during liftoff, are aboard, then Aldrin will be called, and he will take his seat, the middle seat in the spacecraft. The spacecraft commander, Neil Armstrong, and the command module pilot, Michael Collins, now proceeding across the swing arm into the small White Room that attaches at the spacecraft level. In the meantime, about 100 feet below, we have a team of technicians working on a leaking valve, which is a part of the ground support equipment, a part of the system that's used to replenish the fuel supply for the third stage of the Saturn V rocket. He is proceeding to tighten a series of bolts around the system to assure that the leak has been corrected. The spacecraft commander, Neil Armstrong, and CMP, the command module pilot, Mike Collins, now standing by in the White Room. T-minus 2 hours, 38 minutes, 45 seconds and counting. This is launch control. Apollo Saturn launch control, T-minus 2 hours, 34 minutes, 44 seconds and counting. The spacecraft commander, Neil Armstrong, now aboard the Apollo 11 spacecraft at the 320-foot level at the pad. We had it logged having the commander go over the sill into the cabin at 6:54 a.m. Eastern Daylight. Since that time, the commander has now been tied into the system and has checked in over the communication lines. He was wished a good morning by the spacecraft test conductor, Skip Chauvin, and Armstrong in return said it looks like a good morning. In the meantime, 120 feet below him, the technicians continuing to work to tighten bolts around a leaking valve, but on the ground support equipment associated with it. T-minus 2 hours, 33 minutes, 45 seconds and counting. This is Kennedy Launch Control. This is Apollo Saturn Launch Control, T-minus 2 hours, 30 minutes, 55 seconds and counting. Right on the hour, the command module pilot, astronaut Michael Collins, who will be sitting on the right-hand side of the spacecraft during liftoff, boarded the spacecraft. We had it logged at 7 a.m. Eastern Daylight Time. The third member of the crew, astronaut Buzz Aldrin, standing by in the elevator around the corner along the swing arm from the White Room and the spacecraft at the 320-foot level. 120 feet below, technicians still working on some bolts that surround a leaking valve that is associated with a system that replenishes the hydrogen fuel supply for the third stage of the Saturn V rocket. Our countdown proceeding at this time, coming up toward the 2 hour and 30 minute mark in the count. This is Kennedy Launch Control. This is Apollo Saturn Launch Control, T-minus 2 hours, 23 minutes, 46 seconds and counting. The third member of the Apollo 11 prime crew, now aboard the spacecraft. We had it logged at 7:07 a.m. Eastern Daylight Time when astronaut Buzz Aldrin boarded the spacecraft. He will sit in the middle seat during liftoff. As lunar module pilot, his normal position would be on the right-hand side. However, due to crew preference, we have the commander, of course, Neil Armstrong, sitting on the left-hand side, the lunar module pilot for the overall flight, Buzz Aldrin, sitting in the middle seat, and the command module pilot, Mike Collins, sitting on the right-hand seat at liftoff. Down below at the 200-foot level, our technicians still hard at work tightening bolts around a valve associated with this at the 200-foot level. He continues to work at the 200-foot level as the crew in the White Room does the same with the three astronauts aboard. We actually have a fourth astronaut still aboard the spacecraft at this time, astronaut Fred Hayes, who is the backup command module pilot. He is in the lower equipment bay of the spacecraft, giving a helping hand to the three prime crewmen as they start to perform some of their preliminary checks here as we head down over the final 2.5 hours of the countdown. We're at T-minus 2 hours, 22 minutes, 11 seconds and counting. This is Kennedy Launch Control. This is Apollo Saturn Launch Control. We've just passed the 2 hour, 21 minute mark in our countdown, and we are proceeding at this time. At the 320-foot level, all three astronauts now aboard the spacecraft. Just a few minutes ago, astronaut Buzz Aldrin came in and took the center seat to join Neil Armstrong on the left and Mike Collins on the right. These are the positions they will fly at liftoff. During the process of getting the astronauts checked into the spacecraft, communication cables must be attached to their suits. They also have to hook into the suit circuit system of the spacecraft that brings oxygen into their suits. They are helped by a fourth astronaut on board. The backup command module pilot, astronaut Fred Hayes, is in the lower equipment bay, and one of the suit technicians who's located behind them to give a hand as they check in. We've heard from Neil Armstrong, and now we've also heard from Mike Collins on comm checks, and we're standing by for further reports as the checkout continues. 120 feet down, the work continues on a leaky valve at the 200-foot level. This is ground support equipment. The technicians still hard at work tightening bolts around that valve at this time. 2 hours, 19 minutes, 45 seconds and counting. This is Kennedy Launch Control. This is Apollo Saturn Launch Control, T-minus 2 hours, 10 minutes, 35 seconds, and counting. At the 320-foot level, the fourth astronaut aboard the spacecraft regretfully leaves at this time. Astronaut Fred Hayes is about to come out after giving the three prime crewmen a hand in their preliminary checkouts aboard. Hayes will be coming out shortly. In the meantime, 120 feet below, where we had that problem with a leaky valve, the technicians have completed their work, and they are in the process now of departing from the launch pad. In a short while, we'll start flowing hydrogen again back through the general replenishing system to continue to top off the supply of the hydrogen fuel in the third stage of the Saturn V launch vehicle. The spacecraft commander, Neil Armstrong, has completed a series of checks called the Board Advisory System checks. This is where certain key crewmen on the ground, members of the launch team, can send signals to the spacecraft commander in the spacecraft, light cues that would indicate difficulty during the flight in which he could take abort action if he determined that such action was necessary. These checks have been completed, and Neil Armstrong confirmed that the lights came on in the console in front of him, the panel in front of him, as these lights were operated from the ground here in the Launch Control Center. All still going well with our counts. We will stand by as we, again, bring hydrogen back to the third stage. You will see how that operates. We're now at T-minus 2 hours, 9 minutes, 4 seconds and counting. And this is Kennedy Launch Control. This is Apollo Saturn Launch Control, T-minus 2 hours, 7 minutes and counting. At this time, we're just in the process of closing the hatch on the Apollo 11 spacecraft. Several of the closeout crew shook hands with the astronauts and then proceeded to close the hatch on direction from the spacecraft test conductor, Skip Chauvin. We had it logged as the hatch being closed and tightened, still being tightened right at this time, which is 25 minutes past the hour. Once the hatch is closed, we will start a cabin purge to condition the cabin inside. How our hydrogen condition is as far as replenishing the hydrogen fuel supply with the third stage of the Saturn V. 2 hours, 5 minutes, 50 seconds and counting. This is Kennedy Launch Control. This is Apollo Saturn Launch Control. We've just passed the 56-minute mark in our countdown. We're still proceeding in an excellent manner at this time. All elements reporting in that all systems continuing to look good at this point. We're still aiming toward our planned liftoff at the start of the lunar window, 9:32 a.m. Eastern Daylight. A short while ago, in fact, the spacecraft test conductor, Skip Chauvin, informed spacecraft commander Neil Armstrong that we were doing quite well, in fact, some 15 minutes ahead on some aspects of the preparation spacecraft-wise. Armstrong replied that was fine, just as long as we don't launch 15 minutes early, obviously referring to the start of the window. The countdown still going well, T-minus 55 minutes, 10 seconds and counting. This is Kennedy Launch Control. This is Apollo Saturn Launch Control. We've passed the 51-minute mark in our countdown. We're now T-minus 50 minutes, 51 seconds, and counting. Apollo 11 countdown is still go at this time. All elements reporting ready at this point in the countdown. The spacecraft the test supervisor, Bill Schick, has advised all hands here in the control center and the spacecraft checkout people that in about 30 seconds, that big swing arm that has been attached to the spacecraft up to now will be moved back to a park position some 5 feet away from the spacecraft. We alert the astronauts because there is a little jolt when the swing arm is moved away. It will remain in that position some 5 feet away from the spacecraft until the 5-minute mark in the count, when it's completely pulled back to its retracted position. It's coming up now. In 5 seconds. The swing arm will come back. Mark. The swing arm now coming back from the spacecraft. Countdown proceeding satisfactorily. We've completed our telemetry checks with the launch vehicle, and at this point, with the swing arm back, we arm the pyrotechnics so that escape tower atop the astronauts, atop their spacecraft, could be used if a catastrophic condition was going to occur under them with the launch vehicle from this point on down in the countdown. We have the high-speed elevator located at the 320-foot level in the event the astronauts have to get out in a hurry. This is a special precaution. One of the members of the support team for Apollo 11, astronaut Bill Pogue, is here in the firing room. He acts as the capsule communicator during the countdown. His call sign is Stoney. He controls that elevator. He now has it locked at the 320-foot level. These are special precautions for safety purposes during the final phase of the count. Now coming up on the 49-minute mark in the countdown, this is Kennedy Launch Control. This is Apollo Saturn Launch Control. We've passed the 46-minute mark in our countdown. T-minus 45 minutes, 52 seconds, and counting. All elements still go in the countdown at this time. The hard worker in the spacecraft at this point in the countdown, astronaut Buzz Aldrin in the middle seat. He's been working with the spacecraft test conductor on setting up proper switch settings in preparation for pressurizing their reaction control system. These are these big thrusters on the side of the service module. There's actually 16 of them in 4 quadrants around the service module. They are used for maneuvers in space. We pressurize that system before liftoff. That particular operation will be coming up in some 5 minutes or so. In preparation for it, Buzz Aldrin, who has most of the switches in front of him, has been preparing for that particular event. The launch vehicle people keeping an eye on the status of the various propellants aboard the Saturn V launch vehicle. Just at liftoff, we will have a vehicle weighing close to 6.5 million pounds on the launch pad. There's more than 1 million gallons of propellants aboard the 3 stages of the Saturn V. The reports here in the control center are the propellants are stable. We did take a look a little while ago at the RP-1, the high-grade kerosene fuel that's used in the first stage of the Saturn V, to make sure it was at its proper level. We keep an eye on these various aspects throughout the count and use the aid of computers to keep an overall look on general status. We're now at T-minus 44 minutes, 21 seconds and counting. This is Kennedy Launch Control. This is Apollo Saturn Launch Control. We passed the 41-minute mark in our count. T-minus 40 minutes, 53 seconds, and counting. We are continuing, and we're continuing very excellently at this time. There are no problems that have been reported in as the countdown continues to click down. We're still aiming for the start of our window on this, the first flight to land men on the moon. We're aiming toward our planned liftoff time of 9:32 a.m. Eastern Daylight Time. Coming up shortly will be a key test here in the firing room as far as the launch vehicle people are concerned. It's some final checks of the destruct system aboard the 3 stages of the Saturn V launch vehicle. In the event during powered flight that the vehicle strayed rather violently off course, the range safety officer could take action to destroy the vehicle. This obviously would occur after the astronauts were separated by their escape tower from the faulty vehicle. We make a check of the destruct system to assure that if a signal is required to get through, that in fact it will. This is what is coming up here in the control center at this time. All aspects of the mission still go. We're at T-minus 39 minutes, 47 seconds, and counting. This is Kennedy Launch Control. This is Apollo Saturn Launch Control. We passed the 36-minute mark in our countdown. T-minus 35 minutes, 48 seconds, and counting. We've completed those range safety command checks, all still going well with the countdown. A short while ago, spacecraft test conductor Skip Chauvin asked Neil Armstrong if the crew was comfortable up there. And Neil reported back. He said, we're very comfortable. It's very nice this morning. For a status report, we'll now switch to Mission Control, Houston.
This is Apollo Mission Control. Flight Director Cliff Charlesworth's team is on station here in the Mission Operations Control Room, ready to assume the control of this flight at tower clearance. There is a possibility that Apollo 11 will check out the command module color TV camera during the first Earth revolution while in contact with the Goldstone station. If this checkout does occur, we acquire Goldstone at 1 hour 29 minutes elapsed time. We have loss of signal at 1 hour 33 minutes 50 seconds elapsed time. This TV camera checkout is a possibility. This is Mission Control, Houston.
This is Apollo Saturn Launch Control. We've just passed the 31-minute mark in our count for T-minus 30 minutes, 52 seconds and counting, aiming toward our planned liftoff time of 32 minutes past the hour, the start of our launch window on this, the mission to land men on the moon. The countdown still proceeding very satisfactorily at this time. We've just got by an important test with the launch vehicle, checking out the various batteries in the 3 stages and instrument unit of the Saturn V. We remain on external power through most of the count to preserve those batteries which must be used during the powered flight. We've just taken a look at them by going internal and then switching back to external again. The batteries all look good. The next time we go internal will be at the 50-second mark with those batteries, and they will remain, of course, on internal power during the flight. The lunar module, which has been rather inactive during these latter phases of the count, also is going on internal power at this time on the 2 batteries in the ascent stage and the 4 batteries at the descent stage. For the next 20 minutes, we'll take a look at some systems in the lunar module, then power down at about the 10-minute mark in the count, power down the telemetry to preserve the power of the LEM. The lunar module in Apollo 11, of course, when it separates from the command module in lunar orbit, we'll have the call sign Eagle. The command module call sign, once the 2 vehicles separate, will be Columbia. Both Columbia and Eagle are go at this time at 29 minutes, 24 seconds, and counting. This is Kennedy Launch Control. This is Apollo Saturn Launch Control. We've just passed the 26-minute mark in the count. T-minus 25 minutes, 53 seconds and counting. Still proceeding very satisfactorily. At this time, spacecraft test conductor Skip Chauvin working with astronaut Buzz Aldrin in the middle seat, covering the final pressurization of the reaction control system for the spacecraft. These are those big thrusters on the side of the service module that are used for maneuvers in space. Each one of these thrusters is capable of 100 pounds of thrust. There are 16 of them located in 4 quadrants around the service module. We pressurized the system with helium prior to launch to make sure that all will be in readiness for use in space. The countdown still proceeding satisfactorily. It picked up at the T-minus 9-hour mark at 11 p.m. Eastern Daylight last evening. We've just had 2 comparatively minor problems since that time. The major portion of the countdown during the early morning hours, some 5 hours of work was taken to load the various propellants aboard the stages of the Saturn V launch vehicle. As we came into the count this morning, we did already have the fuel aboard the first stage, but it was necessary to bring the liquid oxygen aboard all 3 stages and the liquid hydrogen fuel aboard the second and third stages. Close to 750,000 gallons of propellants were loaded during these 5 hours. Following that, the astronauts, the prime crew, were awakened at 4:15 a.m. Eastern Daylight as planned in their countdown and proceeded to have a physical examination in which they were declared flight ready. They sat down for the normal astronaut fare on launch day. As far as breakfast is concerned, orange juice, steak, scrambled eggs, toast, and coffee. The 3 pilots were joined by 2 of their colleagues at breakfast, Director of Flight Crew Operations Deke Slayton, and the backup command module pilot, Bill Anders, who has been named the Executive Secretary of the National Aeronautics and Space Council. The astronauts departed from their crew quarters after checking out their suits. They departed from the crew quarters at 6:27 a.m., and some 27 minutes later, 8 miles away from the crew quarters at the Kennedy Space Center, atop the launch pad at Complex 39, 6:54 a.m., the commander, astronaut Neil Armstrong, was the first to board the spacecraft. He was followed about 5 minutes later by Mike Collins, and finally Buzz Aldrin, the man who's sitting in the middle seat during liftoff, was the 3rd astronaut to come aboard. 2 minor problems have been encountered during the count. Early in the count, a malfunction light came on here in the control center, indicating that we might have a communication problem at the launch pad. Nothing to do with the spacecraft, but it indicated we possibly might not be able to talk to some key technicians we had at the pad. The problem turned out to be very minor. A simple adjustment of some equipment beneath the pad remedied the problem. There was in fact, no equipment problem involved. The second problem, we did encounter a leaky valve in part of the equipment that's used to replenish the hydrogen fuel supply on the 3rd stage of the Saturn V launch vehicle. A team of technicians were sent out to the launch pad at about the time the astronauts were traveling to the pad. They tightened some bolts, and we were able to bypass this valve and proceed with our countdown. The weather is certainly go. It's a beautiful morning for a launch to the moon. We expect a temperature of about 85 degrees in the Kennedy Space Center area. The wind's about 10 knots from the southeast, and the weather conditions and the round-the-world track, according to reports from the Manned Spaceflight Meteorology Group, indicate all weather conditions are acceptable for launch. That's our general status. We've just passed the 22-minute mark in the count, 21 minutes, 55 seconds and counting. This is Kennedy Launch Control. This is Apollo Saturn Launch Control. We're now less than 16 minutes away from the planned liftoff of the Apollo 11 space vehicle. All still going well with the countdown at this time. The astronauts aboard the spacecraft have had a little chance to rest over the last few minutes or so. At least they haven't been busy with procedures with the spacecraft test conductor. In the meantime, we have been performing final checks on the tracking beacons in the instrument unit, which is used as the guidance system during the powered phase of flight. Once we get down to the 3-minute and 10-second mark in the countdown, we'll go on an automatic sequence. As far as the launch vehicle is concerned, all aspects from there on down will be automatic, run by the ground master computer here in the firing room. This will lead up to the 8.9-minute mark in the countdown when the ignition sequence will begin in those 5 engines of the first stage, the S1C stage of the Saturn V. At the 2-second mark, we'll get information and a signal that all engines are running, and at the 0 mark in the countdown, once we get the commit signal, the signal that says that the thrust is proper and acceptable, we then will get a commit and liftoff as the hold-down arms release the vehicle. We have some 7.6 million pounds of thrust pushing the vehicle upward, a vehicle that weighs close to 6.5 million pounds. We're now 14 minutes, 30 seconds and counting. This is Kennedy Launch Control. This is Apollo Saturn Launch Control. We've passed the 11-minute mark. Now T-minus 10 minutes, 54 seconds on our countdown for Apollo 11. All still go at this time. The astronauts in the spacecraft busy again. The commander, Neil Armstrong, has performed some final switch settings for the stabilization and control system of the spacecraft. The spacecraft also now is on full internal power. This came shortly after the 15-minute mark. The spacecraft now on the full power of its fuel cells. Up to this time, it had been sharing the load with an external power source. Both Armstrong and Buzz Aldrin have armed their rotational hand controllers, the controllers they use in flight. And we have now gone to the automatic system with the emergency detection system, that system that would cue the astronauts if there's trouble down below with the Saturn V rocket during the powered flight. We're now coming up on the 10-minute mark, 10 minutes away from our planned liftoff. Mark, T-minus 10 minutes and counting, T-minus 10. We're aiming for our planned liftoff at 32 minutes past the hour. This is Kennedy Launch Control. This is Apollo Saturn Launch Control. We passed the 6-minute mark in our countdown for Apollo 11. Now 5 minutes, 52 seconds and counting. We're on time at the present time for our planned liftoff of 32 minutes past the hour. Spacecraft test conductor Skip Chauvin now has completed the status check of his personnel in the control room. All report they are go for the mission, and this has been reported to the test supervisor, Bill Schick. The test supervisor now going through some status checks. Launch operations manager Paul Donnelly reports go for launch. Launch director Rocco Petrone now gives a go. We're 5 minutes, 20 seconds and counting. Coming up shortly, that swing arm up at the spacecraft level will come back to its fully retracted position. This should occur at the 5-minute mark in the count. In the meantime, the lunar module telemetry has been powered down. We took a good look at Eagle, and it looks good. The spacecraft test conductor for the lunar module reported that Eagle was go. The swing arm now coming back to its fully retracted position as our countdown continues. T-minus 4 minutes, 50 seconds, and counting. Skip Chauvin informing the astronauts that the swing arm now coming back. The astronauts will have a few more reports coming up in the countdown. The last business report will be from Neil Armstrong at the 45-second mark in the count when he gives a status on the final alignment of the stabilization and control system. We're now passing the 4-minute, 30-second mark in the countdown. Still go at this time. Four minutes, 15 seconds. The test supervisor now has informed launch vehicle test conductor Norm Carlson, you are go for launch. From this time down, Carlson handles the countdown as the launch vehicle begins to build up. We're now hitting the 4-minute mark. 4 minutes and counting. We are go for Apollo 11. We'll go on an automatic sequence starting at 3 minutes and 7 seconds. 3 minutes, 45 seconds, and counting. And the final abort checks between several key members of the crew here in the control center and the astronauts. Launch operations manager Paul Donnelly wished the crew on the launch team's behalf good luck and Godspeed. 3 minutes, 25 seconds, and counting. We're still go at this time. We'll be coming up in the automatic sequence about 10 or 15 seconds from this time. All still go at this time. Neil Armstrong reported back when he received the good wishes. Thank you very much. We know it will be a good flight. Firing command coming in now. We are on the automatic sequence. We're approaching the 3-minute mark in the count. T-minus 3 minutes and counting. T-minus 3. We are go with all elements of the mission at this time. We're on an automatic sequence as the master computer supervises hundreds of events occurring over these last few minutes. T-minus 2 minutes, 45 seconds, and counting. The members of the launch team here in the control center monitoring a number of what we call red line values. These are tolerances we don't want to go above and below in temperatures and pressures. They're standing by to call out any deviations from our plans. 2 minutes, 30 seconds, and counting. We're still go on Apollo 11 at this time. The vehicle starting to pressurize as far as the propellant tanks are concerned, and all is still go as we monitor our status for it. 2 minutes, 10 seconds, and counting. The target for the Apollo just past the 2-minute mark in the countdown. T-minus 1 minute, 54 seconds, and counting. Our status board indicates that the oxidizer tanks in the second and third stages now have pressurized. We continue to build up pressure in all 3 stages here at the last minute to prepare it for liftoff. T-minus 1 minute, 35 seconds on the Apollo mission, the flight to land of the first men on the moon. All indications coming in to the control center at this time indicate we are go. 1 minute, 25 seconds and counting. Our status board indicates the third stage completely pressurized. 80-second mark has now been passed. We'll go on full internal power at the 50-second mark in the countdown. Guidance system goes on internal at 17 seconds, leading up to the ignition sequence at 8.9 seconds. We're approaching the 60-second mark on the Apollo 11 mission. T-minus 60 seconds and counting. Past T-minus 60. 55 seconds and counting. Neil Armstrong just reported back. It's been real smooth countdown. Past the 50-second power transfer. It's complete. We're on internal power with the launch vehicle at this time. 40 seconds away from the Apollo 11 liftoff. All the second stage tanks now pressurized. 35 seconds and counting. Still go with Apollo 11. 30 seconds and counting. Astronauts report it feels good. T-minus 25 seconds. 20 seconds and counting. T-minus 15 seconds. Guidance is internal. 12, 11, 10, 9. Ignition sequence start. 6, 5, 4, 3, 2, 1, 0. Liftoff. We have a liftoff. 32 minutes past the hour. Liftoff on Apollo 11. Tower cleared.
We got a roll program.
Plus 30 seconds.
Roll is complete and the pitch is programming. One Bravo.
One Bravo is a abort control mode. Altitude's 2 miles.
Apollo 11, Houston, you're good at 1 minute.
Downrange 1 mile, altitude 4 miles now. Velocity 2,195 feet per second.
Start model pressure red line is lit. I don't... Where? Yeah, it don't make a difference. No difference. Okay, let's punch them out. Everything is go, Ralph.
We're through the region of maximum dynamic pressure now.
Yeah, everything looks good here. We're at 1350 on the start bottle.
Set 8 miles downrange, 12 miles high. Velocity 4,000 feet per second.
Stand by for mode 1, Charlie. Mark, mode 1, Charlie.
1 Charlie.
Cliff Charlesworth taking a staging status.
This is Houston, you are go for staging.
Inboard cutoff.
Inboard engines out.
I'm inboard cutoff.
Downrange 35 miles, 30 miles high. Standing by for the outboard engine cut down now.
Staging. And ignition.
S4B is go.
11 Houston, thrust is go. All engines, you're looking good.
Roger, you're loud and clear, Houston.
At 3 minutes, downrange 70 miles, 43 miles high, velocity 9,300 feet per second.
All the second stage tanks now pressurized. 35 seconds and counting. We are still go with Apollo 11. 30 seconds and counting. Astronauts report it feels good. T-minus 25 seconds. 20 seconds and counting. T-minus 15 seconds. Guidance is internal. 12, 11, 10, 9. Ignition sequence starts. 6, 5, 4, 3, 2, 1, 0. All engine running. Liftoff. We have a liftoff. 32 minutes past the hour. Liftoff on Apollo 11. Tower cleared.
We got a roll program.
Neil Armstrong reporting the roll and pitch program, which puts Apollo 11 on a proper heading. Plus 30 seconds.
Roll's complete and the pitch is programming. One Bravo.
One Bravo is a abort control mode.
Ignition sequence start. 6, 5, 4, 3, 2, 1, 0. All engine running.
Clock start flight, Roger.
We have a liftoff. 32
Thrusters go all engines, Roger. Flight fighter, go with the IP. Roger, IP.
Neil Armstrong reporting the roll and picture program, which puts Apollo 11 on a proper heading.
Flight range safety is nominal.
30 seconds.
Roger, RSO.
Roll complete and the pitch is programmed. One Bravo.
Flight range safety is in the water. Roger, RSO. Roger.
Altitude.
Okay. We're leaving. Roger, how you, booster? We'll go flight. Good at 1 minute, Captain.
Oh, 11 Houston, you're good at 1 minute. Downrange 1 mile, altitude 4 miles now. Velocity 2,100
Fido, flight, how you?
per second.
Looking good, flight. GNC? Looks good, flight. Ecom? Looking good, flight. Roger.
We're through the region of maximum.
Booster, flight, how you? We'll go flight. Surgeon? We're go flight. Everything's good. Roger.
Set 8 miles downrange, 12 miles high. Velocity 4,000 feet.
Stand by for mode 1, Charlie.
Stand by for mode 1, Charlie.
Mark.
Mark,
Staging
mode
status,
1, Charlie.
booster. Go. Fido. Go. Guidance. Go. Good for staging,
Cliff
Captain.
Charlesworth taking a staging status. This is Houston, you are go for staging. Inboard cutoff. Inboard engines out. And then
Confirm inboard. Roger.
downrange 30
How you
miles, 30 miles
go
an hour,
flight.
standing by for the outboard engine cut.
Or go flight. Roger.
Station. And ignition.
Set off. Ignition. Roger. Trajectory verify. Roger. Thrusters go all engines. Looks good, Capcom.
11 Houston, thrusters go all engines. You're looking good. Roger, you're loud and clear, Houston.
We believe that Mike Collins is now maneuvering the spacecraft in the transposition and docking maneuver, and the antenna patterns aren't too good at the moment. So we have a weak signal strength.
Apollo 11, this is Houston, broadcasting in the blind. Request Omni Bravo. If you read us, request Omni Bravo. Out. Apollo 11, this is Houston, how do you read?
Goldstone still showing weak signal strength.
Apollo 11, this is Houston, how do you read? Over. Apollo 11, this is Houston, do you read? Over. Apollo 11, this is Houston, radio check, over. Apollo 11, this is Houston, radio check, over. Apollo 11, this is Houston, radio check, over. Roger, we're copying you about 5 by 2, very weak. Can you give us a status report, please? Understand you are using the high gain, over.
Affirmative.
Roger, I read you very loud and clear, Buzz. Mike's pretty weak.
Roger, we've got the high gain locked on now, I believe, auto tracking now.
Okay, you're coming in loud and clear, but Mike is just barely readable.
That was Neil. How are you reading, Mike?
Loud and clear now, Mike, and we understand that you are docked.
That's affirmative. Houston, CDR, how do you read distance?
11 CDR, loud and clear, Neil.
Okay. This is Apollo Control. Apollo 11's velocity now 21,096 feet per second. Distance from Earth 6,649 nautical miles.
All right, 11, this is Houston, over.
Hello, Apollo 11. Houston,
says that the TV looks great. Over.
Okay, Roger, we're wrapping in on Earth.
Hello, Apollo 11, Houston, did you copy? Over.
Roger, we copied, Charlie.
Roger, your transmissions the last couple of times have been about 2 by, over.
Okay, how do you read me now?
Right, you're 5 by now.
Okay, we're zooming the lens on in to let just about fill the monitor.
Roger.
Okay, it's in full zoom now.
Copy 11.
And how about the f-stop? Is 22 going to be adequate?
Stand by. We'll get with the Goldstone TV guy. We don't have anything here at Houston. Stand by.
Yeah, that's right. It looks good on the monitor as far as the f-stop goes, therefore we just assume it's okay. Goldstone.
Hello, Apollo 11, Houston. Goldstone says that TV looks really great. 5 by.
Okay, you just cut out, Charlie. We understand that it's looking great. We'll leave it the way it is and wait for you to come back on.
Roger, how do you read me now, over?
Bye-bye.
Okay, my comments were from Goldstone that they see no white spots as we saw in 10. Looks like the AGC's working real well. The F-22 looks good, over.
Okay, very good. Well, we shut out the sun coming in some of the other windows into the spacecraft, so it's looking through the number 1 window, and there isn't any reflected light right now, so it ought to be a pretty good picture.
Roger. Hello, Apollo 11, Houston. We'd like you to keep the TV on for about 10 minutes or so we can get some good comparison on the camera. You can do anything you're...
Apollo 11, over.
Roger, go ahead, over.
Charlie, I'm sorry, you keep cutting out. We heard up to you can do anything, and then after that, we didn't hear anything, and we knew that wasn't right anyhow, but we can't. But what do you want us to do?
Roger, we'll check the uplink on our voice. Our transmission on the TV was we'd like to get about at Goldstone
So we can look at the camera quality back here at Houston for about 10 minutes or so when they patch it back into us. What we were saying was... we'd like a little... Stand by. Start over with we were saying. Hey, Houston, you suppose you could turn the Earth a little bit so we could get a little bit more than just water? Roger, 11. I don't think we got much control over that. Looks like you'll have to settle for the water. Houston, we're going to thinking about changing our voice uplink to another site. If you'll stand by, we'll see if we can improve the quality, over. Okay, Charlie. We'll stand by for your call. Apollo 11, Houston, we'll try once more on this TV request. We'd like 10 minutes worth of TV, and we'd like a narrative, if you could give us one on the exterior shots. We also suggest you might try an interior position, over. Roger, we're seeing the center of the Earth as viewed from the spacecraft in the eastern Pacific Ocean. We have not been able to visually pick up the Hawaiian island chain, but we can clearly see the western coast of North America, the United States, the San Joaquin Valley, the High Sierras, Baja California, and Mexico down as far as Acapulco and the Yucatan Peninsula, and you can see on through Central America to the northern coast of South America, Venezuela, and Colombia. I'm not sure you'll be able to see all that on your screens down there. Roger, Neil. We just wanted a narrative such that we can, when we get to playback, we can sort of correlate what we're seeing. Thank you very much. I didn't see anything but the disky so far. Looks like they're hogging the windows. You're right. Hello, Apollo 11, Houston. On your crowds, we'd like at this time for you to place all 4 cryo heaters to auto and turn off all 4 cryo fans, over. Okay, all 4 cryo heaters are auto. And all 4 cryo fans are off. Roger, that's going to be your sleep configuration. Okay. And Buzz will be terminating the battery charge in about a half hour. Roger. Hello, Apollo 11, Houston, you can terminate TV at your convenience. We've got enough tape, and you can start PTC at your convenience. The rates look super for starting up, over. Roger, Charlie.
Houston, over.
Go ahead, Houston.
11, this is Houston. Goldstone reports they're receiving a TV picture coming down from you all. A little snowy, but a good TV picture, over.
Roger, we're just testing the equipment up here.
Roger.
Ask them if they can read the numbers.
Okay, stand by.
What's showing on the disc key, also whether they can see PROG, BERB, and NOUN, over.
Roger, stand by a second. Goldstone, MNO, Houston, Capcom, over.
Capcom, Goldstone, go ahead.
Roger, did you copy the spacecraft request?
That's affirmative. I am reading the numbers on our monitor here.
Okay, that's similar. Roger, that's both the numbers on the disk itself and the little words like program and verb, noun, computer activity, things of the sort.
Roger, I can read the numbers clearly. We can't distinguish what the words are because it is a little snowy.
Roger. Thank you.
Okay, I read verb, noun, and program.
Yes, Apollo 11.
Go ahead, 11.
Oh, Charlie, is that you?
That's me. How are you there?
Oh, just fine. How's the old white team today?
The old white team's bright-eyed, bushy-tailed. We're ever alert down here.
Ever alert and vigilant. Hey, you got any medics down there watching heart rate? I'm trying to do some running in place down here, and I'm wondering, just out of curiosity, whether it brings my heart rate up.
Well, they will spring into action here momentarily. Stand by. Hello, 11. We see your heart beating.
Okay, well, look at the CDRs and the CMPs, see if they go up any. We're all running in place up there. You wouldn't play that.
I'd like to see that site. Why don't you give us a TV picture of that one?
I think Buzz is trying. You got it.
Okay, it's coming in a ghost zone, Buzz. I guess Bruce said we don't have it here in the center.
Afraid this isn't going to help out the PCC very much. Yeah, I don't know if it's a vibration or what it is, but it makes the pitch and yaw rate needles on FDAI number 1 jump up and down a little bit when we jump up and down.
Right. All right. Ghost on it said he see you running there, Mike.
Okay. Ask him what he's running from.
Houston, Mike, we see about a 96 heartbeat now.
Okay, thank you. Well, that's about all is reasonable without getting hot and sweaty.
All right, Roger, we copy.
Goldstone should be getting about the best picture of the Earth we can get right now, Charlie.
Roger, Mike. Thank you much.
We got a little distortion in the horizontal direction banding on our monitor. I wonder if they're getting the same thing.
Stand by, Buzz. I'll let you know.
Goldstone M&O?
Okay, the cruise is complaining of some horizontal banding on their monitor. Do y'all see that on the picture?
Stand by. They wouldn't see it right now. We don't have anything in focus, Charlie.
Roger. He's checking on it. I'll see if they had it earlier. Stand by.
I guess when we were showing the Disky or when we were showing the Earth might be the better time.
Okay.
Houston, Capcom, Goldstone.
Go ahead.
Okay, our TV people confirm they see this horizontal bend.
Okay. 11, Houston, the Goldstone TV people also see the banding when same time y'all do, over.
Okay, would they call it a horizontal waviness instead of banding, maybe?
No, I'm not talking to them directly. Stand by, Buzz. Let me see how they describe it. Goldstone MNO, Houston Capcom. Could you put the TV guy on the loop, please?
Capcom Goldstone, roger. Houston Capcom, Goldstone MNO, Net 1.
Go.
The TV people do not have access to Net 1 in that area. Suggest we use Net 2 for that purpose.
Okay, going to Net 2. Hello, Apollo 11. Houston, the Goldstone TV guys say that they have some horizontal banding across the upper part of the picture and across the lower part. They would consider the lines just straight, no waviness to them at all, over.
Roger, understand. They do seem to distort vertical lines, though.
Say again about the vertical lines, Buzz.
Roger, when there's a vertical line, these horizontal bands tend to put small waves in it.
Roger, I copy. He didn't mention that. Stand by, I'll check again. Hello, 11, Houston. The Goldstone TV said that when you get a sharp vertical line on a picture where the horizontal banding goes across, it does appear to bend it slightly. It's the same as Apollo 10, they said. Looks okay to them, over.
Okay, I understand. It's not our monitor. It must be the transmitter of the system.
All right, yeah, I guess so, Buzz. We'll have them look into it and see if they can suggest anything.
Houston. Please select Omni Bravo on board, over.
Take on the Bravo, Charlie.
Roger.
How's everything going down there? You guys happy with spacecraft systems?
Roger. Affirmative. Everything's looking really good to us, over.
Okay, same here. Charlie, how far out can you pick up TV off the Omni?
Stand by. Apollo 11, Houston, we're just about at the limits where we can get any kind of picture at all on the Omnis on the TV. The picture, I guess, would be just almost zero at this point. Okay, 11, we have a picture. We see the Earth right in the center of the screen, over.
Roger, Houston, Apollo 11. Calling in from about 130,000 miles out. And we'll zoom our camera in slowly to get the most magnification we can. Over.
Roger. Houston, the definition is pretty good on our monitor here. The color's not too varsity, at least on this set. Could you describe what you're looking at, over?
Roger, you're seeing Earth as we see it at our left-hand window, just a little more than a half Earth. We're looking at the eastern Pacific Ocean, and the north half of the top half of the screen we can see North America, Alaska, United States, Canada, Mexico, and Central America. South America becomes invisible just off beyond the terminator or inside the shadow. We can see the oceans with a definite blue cast, see white bands of major cloud formations across the Earth, and can see coastlines, pick out the western U.S., San Joaquin Valley, the Sierra Mountain Range, the peninsula of Baja California, and can see some cloud formations over southeastern U.S. There's one definite mile storm southwest of Alaska. Looks like about 500 to 1,000 miles. And another very minor storm showing the south end of the screen near the, a long way south of the equator, probably 45 degrees or more south latitude. You can pick out the browns in the landforms pretty well. The greens do not show up very well. Some green showing along the northwestern coast of the United States and northwestern coast of Canada.
Roger 11, it's a pretty good picture on clarity here. We're having, can you tell us, it appears to us that there are two distinct cloud formations trending east-west, one approximately about along the equator and one around 30 or so south latitude. Could you tell us exactly where those cross the land masses over?
Yes, they cross just south of the lower part of Mexico, probably through Central America. That is the equatorial band, which we assume to be the intertropical convergence zone. The other band, which is about 30 south, correctly seems to appear to join equator at the far left, or just beyond the horizon on the left edge of Earth, or at least looks like it's going to join it. We don't have an explanation for that banding.
Roger, Neil. Thank you. It also appears that just to the left of the terminator, up in the northern hemisphere, there's a cloud band trending, a gap in the clouds trending northwest, southeast. It appears to us that comes in about over the northern United States, or perhaps the central United States. Is that about correct? Over.
I can see on the monitor the thing you're talking about, but right now I can't get my eye to the window to pick out just where it crosses the shoreline.
Roger. You guys are doing a good job. It's a real steady picture here. Where clarity is excellent. The color, the clouds are, the whites are distinct. The rest of it looks like to me anyway, on the monitor I'm observing, is a fairly greenish blue, is the way I describe it. Over. It appears that the...
Well, we can't observe observe much green from the spacecraft.
Roger. On this monitor, the land masses appear to be just a darker a grayish color rather than a brown.
Well, it's true that we do not have the depth of color at this range that we enjoyed at 50,000 miles out. However, the oceans still are a definite blue, and the continents are generally brownish in cast, although it is true that they're tending more toward gray now than they were at the closer ranges.
Roger, 11. We've been, I've just been vectored to another monitor, and sure enough, the browns are coming in a lot more distinctly on the iodophore that we have up on our screen in the control center. Over.
Okay, world, hold on to your hat. I'm going to turn you upside down.
Yeah, 11, that's a pretty good roll there.
That's pretty sloppy, Charlie. Let me try that one again.
You'll never beat out the Thunderbirds. Apollo 11 Houston, that practice did you some good. It's looking real smooth roll there. Oops, spoke too soon.
I'm making myself seasick doing it, Charlie. I'll just put you back right side up where you belong.
Roger.
You don't get to do that every day.
11 Houston, could you describe, from your view, the polar cloud cap appears to us to extend down the western coast of North America. Would you estimate how far it extends down? Over.
Trying to fit everybody into the window. It appears that the cloud cap comes down a little bit below the southern extremity of Alaska.
Roger. We've 11. We've lost our picture here now. Okay, Apollo 11 Houston, we've got the picture back now.
Unfortunately, we only have one window that has a view of the Earth, and it's filled up with the TV camera, so your view now is probably better than ours is.
Roger, we copy. 11 Houston, if you could comply, we'd like to see some smiling faces up there. If you could give us some interior views, I'm sure everybody'd like to see you. Over.
Okay, we'll reconfigure the TV for that.
Roger. Apollo 11 Houston, appears to us that we're seeing a view from outside plus a little of the inside. It appears you've taken the camera away from the left window. Now over.
That's correct. We're moving it back and reconfiguring for interior lighting.
Roger. We can still see the Earth through the left window, and it appears that we can see a floodlight off to the left, either that or some sun shafting through the hatch window. much. Now we're coming in. Can't quite make out who that is. Roger. It's a little dark now, 11. Maybe a bigger f-stop might help.
Yeah, that didn't work.
It's getting a lot better now, 11. Mike, you coming in 5 by. I got a good...
Well, I put on a coat and tie if I'd known about this ahead of time.
Is Buzz holding your cue cards for you, over?
Cue cards have a no. We have no intention of competing with the professionals, believe me. We are very comfortable up here, though. We do have a happy home. There's plenty of room for the three of us, and I think we're all learning to find our favorite little corner to sit in. The 0G is very comfortable, but after a while you get to the point where you sort of get tired of rattling around and banging off the ceiling and the floor and the side, so you tend to find a little corner somewhere and put your knees up or something like that to wedge yourself in, and that seems more at home.
Roger. Looks like Neil is coming in 5 by there. 11. Mike, see you in the background. The definition is really outstanding. The colors are good to blanket out, though.
Yeah, Neil's standing on his head again. He's trying to make me nervous.
Roger.
He's disappearing up into the tunnel, of course, as he would going into the lunar module, only backwards.
Roger, we can see portions of the LAB now, the systems test meter panel in the lower part of the picture, or we did have it anyway.
Okay, and then directly behind his head are our optical instruments, the sextant and the telescope that we use to take sightings with.
Roger, copy, and we see the disc keep flashing with a 651. In fact, we can read registers 1 and 2 quite clearly.
Yeah, the old high gain angle telling us which way the Earth is.
Copy. That's a beautiful picture. Clarity is outstanding.
We can also give you the time of day in our system of mission elapsed time, 34 hours, 16 minutes, and 15 seconds.
Roger.
Can you see that clearly enough, Charlie?
Roger, Apollo 11. We can see it counting up every second. We got 34:17:02 now.
Okay, back to the high gain angles.
Roger.
Swing amp. And we've amputated those.
Houston, we have a beautiful rainbow there, and as you move the camera around rapidly, that looks like a star chart coming into view now, over.
Yeah, those are Buzz's 2 star charts that he is using right now as sunshades over the right-hand window, window number 5.
Roger, we see the sun shining in through it behind him and plotting out the the ecliptic plane and the stars that you're using for the navigation.
You're right. He doesn't really need the charts. He's got them memorized. They're just for show.
We copy.
Well, we're pointing up in this direction. We see out our side windows
the sun going by, and of course out one of our windows right now we've got the Earth. Now right behind my window, of course, we have the sun, because the sun is illuminating the star chart that we see. This line represents the ecliptic plane, and these lines, vertical lines, represent our reference system that the spacecraft is using at this time. As we approach the moon will gradually grow larger and larger in size, and eventually it will be in eclipse. It will be eclipsing the sun as we go behind it as we approach the lunar orbit insertion maneuver. Roger, 11. Could you attempt a little bit better focus there, 11, over? Houston, that's a lot better on the star chart now. We can make out the ecliptic plane and the planets and the sun and the moon as they're drawn at various places throughout the ecliptic plane. Over. Okay, Charlie. If we can get some of the wires untangled here, we'll give you a demonstration of how easy push-ups are up here. 11, roger. Good to do a buzz there. When it gets pretty hard doing it that way, why we just roll over and do it the other way. Right, we copy. Couldn't figure out whether that was a chin-up or a push-up. Just take your choice, I guess. Well, looks like it's probably almost your dinner time down there, Earth. We'll show you our food cabinet here in a second. 11, roger. Houston, we see a box full of goodies there, over. Oh, we really have them, Charlie. We got all kinds of good stuff. We've got coffee up here in the upper left, and various breakfast items, bacon in little small bites, and beverages like fruit drink. And over in the center part, we have all kinds of things. Let me pull one out here and see what it is. Right. Would you believe you're looking at chicken stew here? All you have to do is 3 ounces of hot water for 5 or 10 minutes. Now we get our hot water out of a little spigot up here with a filter on it that filters any gases that may be in the drinking water out, and we just stick the end of this little tube in the
into the spigot and pull the trigger 3 times for 3 ounces of hot water, and then mush it up and slice the end off it, and there you go, beautiful chicken stew.
Sounds delicious.
Yeah, the food so far has been very good. We couldn't be happier with it.
Roger.
Run that flashlight a second.
The surgeons are saying thank you there for that.
And it is sort of down in a dark corner, so we have a flashlight here to help us see things. And if I can let go of it carefully, it'll just hold itself right where it is.
Roger.
As long as disturb it will. Well, the problem is no matter how carefully you let go, you bump it just a tiny little bit, set it in motion, and once in motion, there she goes. Try that again.
It looks fairly stable now with slow rotation.
Well, so much for the food department. I'm going to close up the store down here.
Roger, we copy.
Charlie, we checked out the cable lengths, and we're thinking we might want to see if we can take the TV into the LEM with us tomorrow for part of the time. Over.
Roger, good show. We'd like to see it if it'll reach that far. Over.
We'll give it a try.
Roger.
Now, where I sleep is down underneath this couch.
Houston, roger. Slowly sinking into the sack there.
Yeah, it's really comfortable. Forgot to give Buzzy's flashlight back.
Apollo 11, Houston, could you give the folks a view of your patch if on your CWGs, over?
Yeah, stand where I went, Charlie. We'll try to give you a close-up.
All right.
Mm-hmm.
11, Houston, we have the patch. Could you attempt to improve the focus slightly, over? Houston, the scan on the camera makes the, that's a little bit better now. The flashlight seems to flicker due to the scan on the TV. We can't see the eagle. Now that's a little bit better, over. Could you open the f-stop a little bit more, over?
It's open all the way. We're going to have to move buzz around a little bit.
Roger. Okay, Apollo 11, Houston, the color's better now. It's coming in. We could attempt a little bit better focus on it. There we go. Our focus is a lot better now. We see the eagle coming right in on the lunar surface. Over. That's very good now. Apollo 11, Houston, that's very good now. We can see the Earth in the background, Apollo 11, and the eagle coming in.
Probably pretty hard to see the olive branch, isn't it?
Roger, it is.
Well, that's what he has in his talons, is an olive branch.
Copy. Apollo 11, Houston, we're really impressed with the clarity and the detail that we have in the picture. The colors are, now it's really an excellent picture now that I'm looking at on our monitor, which is about 12 seconds before the networks can get it out due to the conversion that we have here on our TV converter. We're looking at the controls and display, the main display console, and we can see the disky up on the panel. Over.
Well, it'd be nice if you could take a look at all the circuit breakers, make sure the right ones are in and the right ones are out.
All right, Big Brother's watching.
Yeah, we're glad of it. Well, you guys sure been doing a good job of watching us, Charlie. We appreciate it.
Spacecraft's been beautiful, 11. We really no complaints at all. Looks, things are really great.
Can you see this disky on the NBC?
That's affirmative. It appears that can't quite tell what program. We look like we're in poo. We see you punching in a verb 35, I think it is. Over.
Yeah, might as well tell the ECOMs or tell the GNCs and everybody to hold on to their hat and I'll push the enter button.
Right. We see a real display now. That's a good demonstration of how the crew has the interface with the computer, talking to the programs and all that we have in the computer.
Well, that's right, Charlie. Sometimes it tells us things, and sometimes we tell it things, and mostly it talks to us.
11, Houston, we just lost our pick. I see we're going back outside now. Over. Uh, 11, Houston, you copy? Over.
Roger, we copy. And as we pan back out to the distance at which we see the Earth, we'll have Apollo 11 signing off.
Roger, Apollo 11. Thank you much for the show. It's a real good half hour. Appreciate it. Thank you very much. Out. Apollo 11, Houston, we are go for undocking, over.
Roger, understand. That's it. Starting a trim maneuver to X-Cal attitude. Houston, Columbia.
Go ahead, Columbia, over.
Roger, there'll be no television of the undocking. I have all available windows either full of heads or cameras, and I'm busy with other things.
We concur, over.
Okay.
And Eagle, Houston, we'd like you to select aft Omni now. It'll be good for both LOS and AOS, over.
Roger, going to aft Omni.
Apollo 11, Houston, 1 minute to LOS.
Columbia, right. Columbia Systems looking at you guys.
This is Apollo Control. We've had loss of signal now. We'll reacquire the spacecraft again on the 13th revolution in about 45 minutes. At the end of this pass, we passed along the go for undocking. That maneuver will occur just before we reacquire the spacecraft on the 13th revolution, and will be followed in about 30 minutes later by a small separation maneuver performed by Mike Collins in the command module. The checkout of the LEM has been going extremely well. Up to now, ahead of schedule, and both vehicles look very good. At 99 hours, 31 minutes, this is Apollo Control, Houston. This is Apollo Control at 100 hours, 14 minutes. We are now less than 2 minutes from reacquiring the spacecraft on the 13th revolution. When next we hear from them, the lunar module should be undocked from the command and service module. We're presently about 25 minutes away from the separation burn, which will be performed by Mike Collins in the command module to give the LEM and the CSM a separation distance at the descent orbit insertion maneuver of about 2 miles. We have some times on the upcoming events. The separation maneuver is scheduled to occur at a ground elapsed time of 100 hours, 39 minutes, 50 seconds. The descent orbit insertion maneuver, which will be performed on the backside of the moon, set for 101 hours, 36 minutes, 14 seconds. And the beginning of the powered descent at 102 hours, 33 minutes, 4 seconds. We're now 55 seconds from reacquiring Apollo 11 on the 13th revolution. During this revolution, we will be doing the separation maneuver. We'll also be giving the crew on the lunar module a go, no-go for the descent orbit insertion maneuver. We'll stand by now to reacquire the spacecraft. We have confirmation of acquisition of signal. We'll stand by for a call to the crew.
Hello, Eagle, Houston. We're standing by, over.
Yes.
Eagle, Houston, we see you on the steerable, over.
Roger, Eagle, I'm docked.
Roger, how does it look?
The Eagle has wings.
Roger.
Looking good.
Roger, Neil. We got if you'll give us poo and data, we got the loads for you.
Okay, you've got it, poo and data.
Roger, and let us know when you're ready to copy. We have a DOI pad and the PDI pads, over.
Can you check our tracking light, Mike? Back off. Okay, I'm ready to start my yaw maneuver if it suits you, Mike. Would look like you're going to be able to do this without Fahrenheit adjusters, Mike?
Go ahead, Houston. Eagle is ready to copy.
Roger, Eagle. Coming at you with a DOI pad. 101361407. Down 81. Minus 00758. Plus. All balls. Plus 000908. Plus, correction, 00572. Perigee, plus 00085. 0. Eagle Houston, if you'd like to try high gain. Eagle Houston, if you'd like to try 212, yaw, 37, over. Pitch 212, yaw, 37, over.
Roger, I think I've got you on high gain now.
Roger, I think I've got you on high gain now. Roger. Got us locked up there, Telecom. Okay, just really...
Coming up on 1 minute to ignition.
How are you looking?
Take in the angle,
Take in the angle.
just want to leave you there. You need that to go in 4 minutes. You're a go. You're a go to continue fire detail. You're a go to continue fire detail. 245. Houston, we got data right. You're still looking good. Good lock on. We got a lock on? Altitude like that? minus 2,900. We got the earth right on our front window. Houston, you're looking at our Delta 8 program line. Looking good that, over. 1202. 1202. Good radar data, altitude now 33,500 feet. Yes, give us the reading on the 1202 program line. We got it. Roger, 330. 330. Looks like about 820. Roger, copy. Roger, copy. 655. We're still there. Same alarm, it appears to come up when we have a 1668. Was it coming down? Yeah, coming down there. Your Delta is beautiful. It looks good. Delta is looks good. Delta is looking good. Should be fine. You can feel it in here when it throttles down. Better in the simulator. Better in the simulator. Things look real close. Things look real close. No flare. Altitude now 21,000 feet. Still looking very good. Okay, looks like it's cold. We got the operator. Altitude 16,400 feet. And I have the window. Descent to fuel. Eagle Houston, it's descent to fuel to monitor, over. That was H crew that wanted to. Coming up on 8. Altitude 13,005. Would you give us an estimated switchover time? Estimated switchover time, please. Nice direction on that velocity, now reading 760 feet per second. P-64. Altitude 9,200 feet. This should be looking great. 64. Okay. Descent rate 129 feet per second. We copy. 5,100 feet per second is good. Coming up 9 minutes. Eagle, you're looking great. Coming up 9 minutes. We're now in the approach phase. Everything looking good. Altitude 5,200 feet. Attitude control is good. Manual attitude control is good.
The pre-PDI attitude prevented good S-band high gain contact, and we had continual communications difficulty in this area, and finally yawed the spacecraft right between 10 and 15 degrees to give the high gain antenna more margin. This seemed to enable a satisfactory high bit rate condition, but it did degrade our ability to observe the surface through the LPD and make down and cross-range position checks.
As I recall, and this is why I kind of like to have those tapes, there was a certain amount of manual tracking being done during this time with the S-band antenna. During the initial parts of powered descent, the auto track did not appear to maintain the highest signal strength. It dropped down to around 3.7, and the ground wanted reacquisition, so I tweaked it up manually. I got the impression that it was not completely impossible to conduct a manual track throughout power descent. You'd not be able to do very much else beside that. But I think it would be possible to do if you had sets of predetermined values that you could set in case you ever did lose completely.
At DOI ignition, which was our first dips maneuver, I could not hear the engine ignite, couldn't feel it ignite, and I wasn't, the only way I was sure that it had in fact ignited was looking at chamber pressure and the accelerometer. So very low acceleration level, required 10%, just off zero. And
What's 10%?
Yeah.
Just doesn't put out the...
I would think it would, after 0 G, it'd throw you against your straps one way or the other and be very apparent.
Now we're pulled down into the floor with the restraint already, and the difference between that and the 10% throttle acceleration was not detectable to me. However, at 15 seconds when we went to 40%, it definitely was. Our downrange position appeared to be good at the -3 and -1 minute point. The ignition point I did not accurately catch because I was watching the engine performance, but it appeared to be reasonably certainly in the right ballpark. Our cross-range position was difficult to tell accurately because of the skewed yaw attitude that we were obliged to maintain for comm. However, the downrange position marks after ignition indicated that we were long. Each one that was made indicated that we were 2 or 3 seconds long in range, and the fact that throttle up essentially came on time rather than being delayed indicated that the computer in fact was a little bit confused in what our downrange position was. Had it known what it was, it would have throttled down later based on engine performance so that we would still hit the right place if in fact it knew it was downrange by a couple of seconds. Then it would be late to throttling down so that it would brake more at a higher throttle level prior to the pitch over. Landmark visibility was very good. We had no difficulty determining our position throughout all the face-down phase of powered descent, and correlating that with known positions based on the Apollo 10 pictures was very easy and very useful.
It was just about at the yaw around maneuver when we, I guess trajectory monitoring from the Disky up to that point agreed very closely, especially in H-dot and VI, with the values we had in the chart. The altitude values were, maybe off by something approaching 500 feet, but again, they were quite close. It was almost immediately after yaw around that, as I recall, the altitude light went out, indicating that we had landing radar acquisition and lock-on. And what do you recall it being? 2,300 feet, something like that?
26 or 700, I believe, is the number I remember. I think it was plus 26 or 27. The yaw around was slow. We had inadvertently left the rate switch in 5 rather than 25, and I was yawing at only a couple degrees per second as opposed to the 5 to 7 that we'd planned, and the computer would not hold this rate, say 1 to 2 degrees a second. It was jumping up to 3 and back to actually changing the sign and stopping the roll rate, and it was then that I realized that clearly we weren't rolling as fast as we needed to be, and I noted that we were on the wrong scale switch. And, so I went to 25 and put in a 5 degree per second command, and it went right around. But this delayed us somewhat, and consequently we were at a slightly lower altitude at the completion of the yaw round than we had expected to be. So we were probably down to the area of 39 or 40,000 feet at the time when we had radar lockup, as opposed to about 41,000 that we expected to be at 41.5.
I guess the first indications we had of anything going wrong were probably around 5 minutes or something. When we first started getting program alarm activities.
After the 5 minute into descent, we started getting a series of program alarms, generally of the series that indicated the computer was being overloaded. Normally in this time period, we'd normally be evaluating the landing site and checking our position and starting LPD activity. However, the concern here was not with what was the landing area we were going into, but rather could we continue at all. And consequently, our attention was directed toward clearing the program alarms, keeping the machine flying, and assuring ourselves that control was adequate to continue without requiring an abort. And most of the attention was directed inside the cockpit during this time period, and in my view, this accounts for our inability to study the landing site and final landing location during final descent. It wasn't until we got below 2,000 feet that we were actually able to look out and view the landing area.
Okay, looks like it's hold.
Okay, I see something here that answers a question we had before about the AG's residuals on DOI. They were
7 minutes, 30 seconds into
1/10 before nulling, and we nulled them to 0.
altitude 16,000.
X was minus 0.1, Y minus 0.4, Z minus 0.1, and we nulled X and Z to 0.
Okay. Eagle, Houston.
And looking at the transcripts, we did have considerable loss of lock approaching PDI. And we did have to reacquire manually several times.
Roger, stand by. You're looking great at 8 minutes.
And it looked like we had some
760 feet per second. It's the P-64.
oscillations in the yaw
Roger.
angle on the antenna.
Fido says we're go. Altitude.
And the alarm that we had was 500. And we went to descent 1 and proceeded in the computer, and then went back to auto again on the landing radar switch. And this is prior to ignition again, and the ground recommended we yaw right 10 degrees.
Looking great. Coming up 9 minutes.
We did not have the radar data feeding to the computer in the LGC position, but apparently even if you have it in auto track, why there's some requirement on the computer's time to
Altitude 4,200. Houston, you're a go for landing. Over.
This is the way we'd been doing it
Go for landing. 3,000 feet.
in all simulations. It was our agreed on
1201. Roger, 1201 alarm.
method.
We're go. Same tide. We're go. 2,000 feet. 2,000
We were in
feet.
sloop.
Into the ag, 47 degrees. Roger.
Yeah, we were, prior to this time, we'd been in auto track until such time as we started to lose lock in the pitch over, and then we went to sloop.
Eagle looking great. You're go.
Isn't that right?
Altitude 1,600.
Talking about the program alarms during descent? We'd passed the point of having the rendezvous radar in auto. We'd switched it over to slew at that point. Just left it there.
750.
In the early phases of the P-64, I did find time to go out of auto control and into manual and check the manual control in both pitch and yaw, and found its response to be satisfactory, and then zeroed the air needles and went back into auto. Continued the descent in auto at that point.
Gate forward.
As we approached the 1,500-foot point and the program alarm seemed to be settling down and we committed to continue, we could see the landing area and the point at which the LPD was pointing, indicating we were landing just short of quite a large blocky rim crater surrounded with a large boulder field. I initially felt that that might be a good landing area if we could stop short of that crater and find a suitable place, since it would have a lot of scientific value to be in that area close to this large crater.